Okay, today we're going to do practice 11.2a and b, and that is testing a hypothesis about a population mean with sigma known and part B is sigma unknown. So we're going to do this all in one day. So last class period we talked about the steps in the hypothesis test and how there were 6 steps in the hypothesis test. Now we are still going to focus on that, but last class period we only focused on step 1, which was determining the null and alternative hypotheses. Goodness, I can't talk. Determine the null and alternative hypotheses. So that's what we did last class. Today we're going to focus on steps 2 through 6. So step 2 says that we're going to specify the significance level, which again is just another way of saying alpha. Okay, so the significance level is alpha. Now sometimes that's given. You can look over here. Sometimes that's given. It'll say a significance level of 0.02. But sometimes we have to find it. They'll just tell us a confidence interval or a confidence level of 98%. Okay. Step 3 says we're going to have to validate the assumptions of the hypothesis test, identify the appropriate test statistic, and it compute its value. So what they mean by validate the assumptions of the hypothesis test means we're going to have to figure out, like, is the information they're giving us, is the information that we put in our hypotheses like okay, and then identify the appropriate test statistic. That means we're going to have to determine, is sigma known or sigma unknown? Now, just like when we did in Unit 2, if sigma is known, we're going to be using our z value, and if sigma is unknown, we're going to be using our t value. Okay, so to do that, we have to use this incredibly complicated formula. Like my z value when sigma is known is x bar minus my mu sub 0 over my sigma over the square root of n. That's gross, that's a lot of work, but I have a gift for you. Instead of making you figure this out every single time by yourself, I am going to give you a template. So if you go to Canvas, under Resources, and I also have it linked on the agenda, you will see what's called a template for hypothesis testing. Okay? Now, when you open it up, if you need to pause the video and go open it up, that's fine. It's going to look like this. Unit 3 Excel Guide, Templates for Hypothesis Testing. This only works on Excel 2016 or later, but that's okay. We all have that. Now, you do get to use these on the test. So let me explain what this means. It said you should use these templates to help you on your test and Hawk's Learning Systems problems. You can also use them on activities as well as the set of practice problems. These templates will be provided as shown within the Excel sheet for use on the Unit 3 exam and on the final. Here's how to use the templates correctly. First of all, you have to base the claim in the problem. All right? You have to choose the correct template based on the information that you're given. So I'm not going to tell you which template you have to use, and we have quite a few templates that I'm going to give you. All right? Now, you need to highlight the entire template, including the title. The title is really important, and Control-C to copy. Then you're going to go back to your problem, you're going to paste, and you're going to put in all the information. Then it will give you the values for you. Okay, so I'm giving you that template so you don't have to work this out every single time. We'll get some practice with that in a little bit. Then we're going to go to step 4, and it says determine the critical values or p-values. There's two different things. There's a critical value method and a p-value method. So if we're using the critical value method, we're going to find the critical value, and then we'll draw a graph and figure out if it's in the rejection region or the fail to reject region. And then the p-value method is something we're going to come back to in a little bit. I'm going to explain that after we get some practice with the critical value method. Now, those critical values and p-values, that's all going to come from the template, so just chill out with that. Then after you use your method, you're going to make the decision. Either you're going to reject the null hypothesis or you're going to fail to reject your null hypothesis. Then you're going to state your conclusion in terms of the original question. So those are the 6 steps of the hypothesis test. We should be pretty good at null and alternative hypotheses by now. Let's give it a shot. So on number 1 it says, an automobile manufacturer claims that its van has a 40.3 miles per gallon rating. An independent testing firm has been contracted to test the miles per gallon for this van since it is believed that the van has an incorrect manufacturer's mile per gallon rating. After testing 250 vans, they found a mean mile per gallon of 39.9. Assume the standard deviation is known to be 2.4. A level of significance of 0.05 will be used. State the hypotheses. So for this question, all they want us to do is state the null and alternative hypothesis, which is fine. But I also want to get some practice on identifying all the other information that they gave me in this problem. So let's look at it again. An automobile manufacturer claims that its van has a 40.3 miles per gallon rating. That's going to be our mu, okay? So when we're finding our miles per gallon rating, or when we're finding our null hypothesis, we know that we're going to be using mu because it's an average, right? Miles per gallon, it's an average, and it's going to be mu equals 40.3. Now, in the past, we have just written mu equals. If you guys actually want to use the symbol so you don't have to type it out, you can. You can come up here to Insert, and then if you come over here to Symbols, click on Symbol, and it's going to come up with a ton of options. Now mine are down here in recently used, but you can scroll until you find it. Mine's right here. You're going to click on it, and you're going to click Insert, and then close this. And right there, it's going to type it into your cell, and you can keep typing. So mu equals 40.3. Okay, that's really, it looks really big for some reason. Huh. Okay, mu equals 40.3. Now, an independent testing firm has been contracted to test the miles per gallon for this van since it is believed that the van has an incorrect manufacturer's mile per gallon rating. Now, they didn't say that it's too large or too small. They just said incorrect, which means that my alternative hypothesis, H sub A, is going to be not equals to. So again, I'm going to come back to my symbols, and I'm going to insert mu. If you don't want to insert mu, that's okay. You can just put mu. I'm okay with that. Now, instead of, like, since I can't type not equals to, instead of writing it, sometimes you do it with your fingers, we also have the symbol for not equal to in this symbols. So we can insert and close that again, and then mu is not equal to 40.3. And there we have it. Those are my null and alternative hypotheses. Let's see what else they gave me. They also said, after testing 250 vans, well dang, that right there is my sample. So my sample size is 250. They found a mean miles per gallon of 39.9. So this would be the mean of my samples. So that's going to be X bar, so 39.9. Assume that the standard deviation is known to be 2.4. When they say that, assume that it's known. That means that's going to be a population. So the population standard deviation, or sigma, is 2.4. Again, if they say known to be, that doesn't mean they found it. That means they previously knew it, which means that it would be a population standard deviation. And then finally it says a level of significance of 0.05 will be used. That's going to be my alpha, 0.05. Okay, so that's all the information they give me in a problem, and we are going to use that in future problems. This one was just a refresher on how to find null and alternative hypotheses. Let's go to number 2. An engineer designed a valve that will regulate water pressure on an automobile engine. The engineer designed the valve such that it would produce a mean pressure of 7.2 pounds per square inch. It is believed that the valve performs above the specifications. The valve was tested on 290 engines, and the mean pressure was 7.3 pounds per square inch. Assume the standard deviation is known to be 0.06. A level of significance of 0.02 will be used. Determine the decision rule. So we're going to talk about what the decision rule means in just a minute. Let's kind of write down all of our information that we are given here and figure out our null and alternative hypotheses. So an engineer designed a valve that will regulate water pressure on an automobile engine. The engineer designed a valve such that it would produce a mean pressure of 7.2 pounds per square inch. So again, we're dealing with mean here. That's going to be mu. So I'm going to come over here and I'm going to insert symbol, and I want it to be mean. Insert that. And it's going to equal 7.2. And then it says it is believed the valve performs above the specifications. Well, that tells me that my alternative hypothesis is still going to be mu, and above means it's going to be greater than. So I want it to be greater than 7.2. I really don't know why that's so big. That really bothers me. Oh, yeah. should not be 16.5. Let's go back up to, there we go. Okay, so above means greater than. Okay, now let's type in all the other information we can find. It says the valve was tested on 290 engines. Well, that's my N value. So 290 engines. And the mean pressure was 7.3 pounds per square inch. So again, this is on my sample, so that's going to be X bar. The mean pressure was 7.3 pounds per square inch. Assume the standard deviation is known to be 0.06, so I'm going to come back here to symbols. Standard deviation is sigma. You can find it in there too, or you can type it. It doesn't matter. It's known to be 0.6, 0.6. And then a level of significance, which is alpha. And again, guys, you can actually find alpha in those symbols, but I just like to type alpha. It makes more sense to me, in 0.02. Okay? Now it says determine the decision rule. The decision rule right here, here's what it's going to look like on Hawks. It's going to say reject the null hypothesis if z is greater than, and it's going to have a colon, and then it's going to have a box for your answer. So before we can figure out what to put in that answer, let's talk about how we're going to figure all of this out. And actually, it's all dependent on the alternative hypothesis. Okay? The alternative hypothesis, like we said, is going to have one of three symbols. It's either going to have a greater than symbol, a less than symbol, or a not equal to symbol. All three of those are our options. If your alternative hypothesis has a greater than symbol, I'm going to come over here and write some notes. If your alternative hypothesis have a greater than symbol, that means you are going to have a right-tailed mean test. Okay? Again, how do I know it's mean? It's because it literally says the mean pressure. Okay? So it's going to be a right-tailed mean test. Okay? If it's going to be less than, you always follow the direction that it points. That means it's going to be left-tailed. And again, like here, we know it's going to be mean because of this specific problem. And then finally, if it's a not equal to symbol, that means it's going to be two-tailed. Okay? So greater than is right-tailed, less than is left-tailed, not equal to is two-tailed. It's all dependent on that alternative hypothesis. So here I have a greater than, and since we're talking about mu, that's going to be a right tail, and again, it's going to be a mean. But something else that's important is that we do know sigma. Assume the standard deviation is known, so that means I'm going to have sigma known. Okay, so right tail mean, sigma known. Now what we're going to do is we're going to go to our templates. Okay, and again, we said right tail because it's greater than, mean because we have mu, and sigma known. So what I want to do is I want to find my template for a one-tailed mean, known you can see here, two-tailed mean, one-tailed mean, sigma known. So I want a one-tailed mean, sigma known. And you're going to copy that entire table. Highlight the whole thing, including the title. So Control C. Then we're going to come over to this problem, and we're just going to copy and paste it into the problem. Now you'll notice it says we can't do that to a merged cell. Sometimes that happens. That literally just means you don't have enough room in between that problem and the next. So I'm just going to insert some more rows. So what I'm going to do is I'm going to come over here to the rows, highlight however many I want to insert, and then I'm going to right-click, and I'm going to go Insert. That'll shift it down. But you will have to go back and Control Copy that again. So once I have that copied, come in here and paste it. And when you enter this information into the template, it's going to give you all of this information. Now, if you'll notice, like you can click on it and it'll tell you how to find it. Like the critical value is norm.s.i&b. We know how to find that. We did that all of Unit 2. We're just giving you a template so it does it for you. Here's how you work the template. You put in the numbers only where the red text is. You leave the black text alone down here. It will fix that on its own. You just put in the information on the red text. So the first thing they want is the significance level. Okay, the significance level is just another way of saying alpha. We said our alpha was 0.02. Then our X bar we said was 7.3. Our mu we said was excuse me, our mu we said was 7.2, our sigma, because sigma is known as 0.6, and then my sample size. My sample size we already said was 290. Okay, so we put in all of that information, and if you notice, as we filled that in, it corrected itself down here. That's what the whole template is about. All right? So let me double check that. 0.02, 7.3, 7. Oh, that should be 7.2. My bad. 7.2, 0.6, and 290. So now this is a right-tailed mean, sigma known. That means we're focusing on this guy right here. Now, what does that mean? That's my critical value. The critical value is this guy right here because it's right-tailed. So if I were to sketch this as a picture, we're going to have our normal curve, standard normal curve, where my mean is 0. Okay? Now, 2.05 is going to be somewhere over here. So 2.05, I'm just going to put that right in there. 2.05. Whoa. Now, since this is a right-tailed, anything greater than that, anything over here, this is our rejection region. This is our rejection region. Okay? And then anything over here to the left of it, that is our fail to reject region. Now you might be wondering, what in the heck does that mean, Mrs. Getz? I don't understand. Well, here's what that means. We said the critical value is 2.05, but the test statistic right here, now if you're like, what the heck is that? Come look over here. They just find the z-value of this actual problem. This represents their the z-value of their sample that they did with an x-bar of 7.3 and with the sigma known. So the test statistic is 2.83. Now I need to figure out where that is going to lie on my curve. So 2.83 or 2.84 is actually going to be over here somewhere. This is 2.84. Now, if you'll notice, that point, that test statistic, lies in the rejection region, which would mean that we would reject the null hypothesis. Okay, we would reject the null hypothesis. So, this right here is my rejection region based on my right-tailed value. This is my fail to reject region. My test statistic, so the information that I got from my sample, is in that rejection region. So we would reject the null hypothesis. Now, that does not mean that we would accept my alternative hypothesis. That doesn't mean that. That's not our job right now. We just have to figure out, do we reject or fail to reject the null hypothesis? So, the problem said an engineer designed a valve that will regulate the water pressure, blah, 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 so that it would produce a mean pressure of 7.2 pounds. So I said my null hypothesis is that the population mean was 7.2 pounds per square inch. And my stats, my data told me that I'm rejecting that. I'm rejecting that null hypothesis. So it says determine the decision rule. The decision rule is right here. And it says reject the null hypothesis if z is greater than what? Well, we said the rejection region was greater than 2.05, so it's going to reject it if it's greater than that right-tailed critical value, 2.053749. Now, it did not tell me what to round to, so here's what I'm going to do. I'm going to put in equals, and then I'm just going to do that cell reference. They can round it to however they want. Okay, now mostly they will tell you how to round it, but they did not on this one. So that is rejection. That is what I want to reject it if it is greater than. Okay, let's go down to number 3. An automobile manufacturer claims that its Jeep has a 31.3 miles per gallon rating. An independent testing firm has been contacted to test the miles per gallon for this Jeep since it is believed that the Jeep has an incorrect manufacturer's miles per gallon rating. After testing 280 Jeeps, they found a mean miles per gallon of 31.4. Assume the standard deviation is known to be 2.1. A level of significance of 0.05 will be used. Find the value of the test statistic and round your answer to 2 decimal places. So, from this information, we need to figure out my null hypothesis, my alternative hypothesis, and then I just want to document all of the other things that I found. So first I'm going to find my null hypothesis, then I want to find my alternative hypothesis. So my null hypothesis, let's read it again. An automobile manufacturer claims that its Jeep has a 31.3 miles per gallon rating. So I want to insert a symbol here. That's going to be mean. So mean equals 31.3. And again, I don't know why that is so big. Okay, 31.3. The alternative hypothesis comes from the second sentence. An independent testing firm has been contacted to test the miles per gallon for Jeep since it was believed that the Jeep has an incorrect manufacturer's rating. That means that it's not greater than, not equal to, just incorrect. So I'm going to go back to my symbols, and I'm going to say mu insert is not equal to insert, close, and then 31.3. Again, I'm going to change that because that drives me crazy. Okay, mu is not equal to 31.3. Now let's go through and identify the rest of the information they gave us. After testing 280 Jeeps, that's my sample size, they found a mean miles per gallon of 31.4. So that's my X bar, 31.4. Assume the standard deviation is known, so that is going to be my population standard deviation. That's going to be my sigma. Assume that it is going to be known to be 2.1. A level of significance, so that's alpha, of 0.05 will be used. Find the value of the test statistic and round your answer to 2 decimal places. So they just want the test statistic, but that still means we can use our templates. So let's figure out which template we are going to use based on the alternative hypothesis. So first thing I notice here, I notice that my hypothesis, my alternative hypothesis, is not equal to. Not equal to means it's going to be two-tailed. Then I have a mu, which means it's going to be mean, and I do know sigma here, so sigma known. Now before I go copy the correct template, I know there's not going to be enough room in here, so I'm going to go ahead and highlight below it. Oh, that's not what I wanted. Highlight some rows below it, and I'm going to go ahead and click Insert because I want some space. And then I can go back to my templates, and I said two-tailed mean sigma known. So here's what I got, a two-tailed mean sigma known. Highlight the whole table, including the title, copy it, and come back over here, and we're going to paste it in here. Okay, and then we just have to go in and fill in only the information with the red text. So the significance level is 0.05, that's already in there. Whoa. And then my X bar, we said was 31.4. My mu was 31.3. Sigma is known to be 2.1. And my sample size is 280. Okay, so here's all the information that they gave us. Now first of all, this is a two-tailed mean, which means that if I were to draw this, here's what we got. I've got my standard normal curve. My mean is here at 0. Two-tailed means I'm going to use both of these critical values. So they're going to be the same, just one's positive, one's negative. This is going to be negative 1.96, and this is going to be positive 1.96. Now a two-tailed means that I'm going to have two rejection regions. Regions. So both of these guys over here and over here are rejection regions. Gosh, I can't spell today either. And then if my test statistic falls anywhere in this blank spot here, that is going to be the fail to reject region. So let's see what kind of test statistic they gave me here. They gave me a test statistic of 0.7968, so that would be 0.80. Well, 0.80 would be in between 0 and 1.96, so it's going to be about right here. That is going to be my test statistic of 0.80. And if you'll notice, that is in the fail to reject region. That's in the fail to reject region. That means we fail to reject my null hypothesis. Again, that does not mean that my null hypothesis is true. It just means based on the sample that we tested, it didn't give us the information to say that it wasn't true. Now let's actually answer the question. The question said, find the value of the test statistic, which is nice because it gives it right here, round your decimal or your answer to 2 places. Now my test statistic is a z-value because the sigma is known, and to the nearest tenth we could just come over here and go equals cell reference, and then I could just say, hey, I want that rounded to the nearest tenth and move my decimals, but it should be 0.80. All right. Let's go down to number 3. An automobile manufacturer claims that its van has a 36.2 miles per gallon rating. An independent testing firm has been contracted to test the miles per gallon for this van since it is believed that the van has an incorrect manufacturer's miles per gallon rating. After testing 220 vans, they found a mean miles per gallon of 36.0. Assume the variance, be careful there, variance is known to be 4.41. A level of significance of 0.05 will be used and make a decision to reject or fail to reject the null hypothesis. So here's what I'm going to do. I'm going to pause the video. I want you guys to pause the video, and I want you to just come over here and list all the information that you got, your null hypothesis, your alternative hypothesis, and list all the other information that you can find from this problem. Then we'll come back and check it and do the template together. Okay. So from this problem, my null hypothesis is that my mean is 36.2, and my alternative is that my mean is not equal to 36.2 because it just says incorrect. I found my sample size, my sample mean, but here's where things are different. I found the variance, not the standard deviation. Now I can get the standard deviation from that, but here I found the variance. So I put sigma squared is 4.41, and my alpha was 0.5. Now, some people choose to put a line under that to automatically find sigma, but I'm going to teach you a little trick once we get the template here. Now let's figure out what template we need to find. So I have my alternative hypothesis here, red ink. I have my alternative hypothesis, and it says not equal to, so that's going to be two-tailed. And then we're dealing with mu, so mean. And we do have sigma, so it's going to be sigma known. So let's go to my templates, and I want two-tailed mean sigma known. So again, that's what I want to copy, but I forgot. I don't think I have enough space here. I definitely don't. So let's highlight and insert, and I'm going to go back and copy that template, and then I'm going to paste it down here. Okay. Now, to input this in, I want my significance level. It's still 0.05. That's nice. My x-bar is 36.0. My mu was 36.2. Now my sigma, watch what I do here. This is my sigma squared, and we are not allowed to round anything when we put it in here. That's really important. So I can come right in here, and I can type in equals square root of, and I can do the cell reference 4.41, and it'll still work. You can do like formulas inside of the templates. It still works. That being said, like on Hawk's Learning, if they don't give you the x-bar and they give you the actual sample like over here and you have to copy it and you have to find the x-bar, you can type it right in here, equals average of, and you can highlight the whole thing. So just so you know, those are okay to put into your templates. And then finally we have a sample size of 220 here. Now again, this is a two-tailed mean, so we want both of them. Let's sketch what this would look like. I'm going to have my standard normal curve, zeros in the middle. I have a z-value here of 1.96 and a z-value here of negative 1.96. And let's shade that rejection region. Okay. Now I want to figure out my test statistic. My test statistic here is negative 1.41. So 0, negative 1.96. It's going to be right there, negative 1.41. And you'll notice that it is in the fail to reject region. It's in the fail to reject region. So it says, make a decision to reject or fail to reject the null hypothesis. Since it is in this region, we say fail to reject the null hypothesis. And we're just going to highlight that as our answer. Okay? Now, What we've been doing every time here with the critical values and the test statistic, all three of those, with drawing the picture and figuring out if it's in the rejection region or the failed to reject region, that is called the critical value method. That is the critical value method to determine if we reject the hypothesis or fail to reject the hypothesis. Now what we're going to do is we're going to look at the p-value method. Now the p-value is based, it says find the p-value based on the value of the test statistic and the alternative hypothesis. So check this out. The p-value method down here below this, I'm going to talk about it just a little bit more. It says, goodness, scroll. In the previous example, we used a critical value approach for hypothesis testing. However, most researchers use the p-value method for hypothesis testing. While the decision-making of these methods are equivalent, they're going to get you the same answer, the conclusion phase of the p-value method is much simpler. So here's what a p-value is. A p-value is the probability of observing a value of the test statistic as extreme or more extreme than the observed one, assuming the null hypothesis is true and all the assumptions related to the hypothesis test are satisfied. Now, if you're going to perform a hypothesis test using p-values, here's what it means. If the computed p-value, so if that probability is less than your alpha, less than your significance value, you're going to reject the null hypothesis. Okay? If the p-value is greater than alpha, you're going to fail to reject the null hypothesis. There's actually a little phrase that one of my former teachers taught me, and it's very catchy. It's going to help you a lot right here. And that phrase is, if p is low, the null must go. If p is low, the null must go. Also, if p is high, the null must fly. So if p is low, the null must go. We have to reject it. All right? If p is high, the null must fly. We're going to accept it. So what that means, let's go back up to these three problems that we just did, number 2, 3, and 4. Let's look at number 2. On number 2, we already said it was in the rejection region. We're saying we rejected the null hypothesis. Well, let's see if that works out. Now, my p-value here is 0.002268. And my sigma, or not my sigma, my alpha, my significance level right here is 0.02. Now, 0.002 is less than my alpha, my 0.02. Okay, so my p-value here is low. If p is low, the null must go. We reject the null hypothesis. Let's see if that works on number 3. Here on number 3, it was in the fail to reject region, so let's see if that works. My p-value is 0.43. And my alpha, my significance level, is 0.05, and 0.43 is greater than 0.05, my alpha. So here my p-value is high. If p is high, the null must fly. We fail to reject it. All right, let's see if that works again on number 4. On number 4, my p-value is 0.16. My significance level is 0.05. 0.16 is greater than 0.05. If p is high, the null must fly, and that means we fail to reject it, and that's exactly what we came up with. So that's the p-value method. So critical value and p-value method, they give you the same results. It's literally up to you which method you want to solve by. Okay, on number 5. A manufacturer of potato chips would like to know if its bag filling machine works correctly at the 404 gram setting. It is believed that the machine is underfilling the bags. A 48 bag sample has a mean of 400 grams. A level of significance of 0.02 will be used. Is there sufficient evidence to support the claim that the bags are underfilled? Assume the variance is known to be 256. So again, I'd like you to pause the video and give me all the information that you can find from this problem. Okay, so from this problem, I got my null hypothesis to say that we think the population mean is 404 grams. Okay, that's what they wanted. But this says it's believed that the machine is underfilling the bags, so we want the alternative to be less than 404. My sample size is 48. My X bar is 400. My variance is 256. Be careful on that. That's variance. And my alpha is 0.02. So from this problem, I know that we have less than symbol, so that means it's going to be a left-tailed, so that's going to be a 1 tail. And then again we have mu, that means mean, and here we're going to have sigma known. So let's see if I have enough space. I might want to add a couple more rows. I don't really know. I don't want to have to go back, so I might add a couple more rows here. Let's go highlight and copy over the table from the template of one-tailed mean, sigma known. One-tailed mean, sigma known. Get out of here. One-tailed mean, sigma known right there. We're going to copy it, and we're going to bring it, goodness, get out of here. We're going to bring it right on over. We're going to paste it right there. Okay? Now we're going to take a minute, and we're going to type in our information. My significance level on this one is 0.02. My X bar is 400. My mu, my population mean, is 404. My sigma is going to be the square root of sigma squared. So you can type in square root of 256, or we all know that should be 16. You can type that in as well. And my n value here is going to be 48. Okay? Now, we have two ways to do this. We can do it the critical value method, or we can do it the p-value method. Let's start by p-value, and then we'll check it with critical value. So first of all, my p-value here is 0.04, and my significance level is 0.02. That means 0.04 is greater than 0.02. Now, if p is high, the null must fly. That means we fail to reject it. If p is high, the null must fly. We fail to reject it. Let's see if that checks out with my critical value method. So I have this guy right here. It is, here's my 0. It's a one-tailed test, and it's going to be less than, so it's left-tailed. Goodness. So that means I'm going to use this guy right here. Negative 2.05. And then my test statistic is negative 1.73, so right there. Negative 1.73, and that is in the fail to reject region. So we were right. When p is high, the null must fly. We fail to reject it. So let's answer the question. The question said, I don't know why that's going up there. I don't like that. Stop that. I guess we're just going to move with it. Okay. Is there sufficient evidence to support the claim that the bags are underfilled? We are failing to reject the null hypothesis. So here's what this means. There is not sufficient evidence to support the claim that the bags are underfilled. So when p is high, the null must fly. There is not sufficient evidence to claim that the bags are underfilled. There is not sufficient evidence to support the claim that the bags are underfilled. So again, when they say we fail to reject the null hypothesis, we fail to reject it, that means that there's not enough evidence to say that they are underfilled. There's not enough evidence. All right, let's go to the next part. I need that to stop. Can you stop, please? Now, the next thing we're going to talk about is what happens when we test a hypothesis about a population mean, just like we have been doing, but this time sigma is unknown. This time we don't know the population standard deviation. The only difference is this guy right here, my test statistic. Now, my test statistic, when sigma is known, is a z, just like we did last unit. And the test statistic when sigma is unknown is a t. So that's a big difference, a z value versus a t value, two different distributions. The other thing that's different is when it was known, we obviously use sigma, and when it's not known, we're just going to have to use my sample standard deviation, my s value. So let's look at number 6. Using traditional methods, it takes 8.4 hours to receive a basic flying license. A new license training method using computer-aided instruction has been proposed. A researcher used the technique with 16 students and observed that they had a mean of 8.2 hours with a variance of 1. A level of significance of 0.5 will be used to determine if the technique performs differently than the traditional method. Assume the population distribution is approximately normal. Find the value of the test statistic. Round your answer to 3 decimal places. So some things that I noticed here. They do have a sample, but they only find the sample mean. They didn't say, or it says they a researcher used techniques with 16 students and observed that they had a mean of 8.2 hours from the sample with a variance of 1. So that right there is in the same sentence referring to the sample. That is my sample variance. So that means my sigma is not known here. Well, let's list things that we know. So first of all, we're going to find my null hypothesis. And my null hypothesis was that it takes 8 hours to receive a basic flying lesson. So I'm going to go to my symbols and say that mu equals 8.4 hours. And then my alternative hypothesis comes from later on in the problem, and it says if the technique performs differently. So they didn't say less than or greater than, they just said differently. So that means mu is not going to equal the 8.4 hours. That means differently. Now let's go through and find out what else we know. It says a researcher uses a technique with 16 students. That's my sample size. And then it says they had a mean of 8.2 hours. Well, that's in my sample, so that's X bar, 8.2, and a variance of 1. That was my sample variance. Now, this is a really easy to understand variance, so we could easily get our sample standard deviation just by square rooting that. So I'm going to say variance here is 1.00, and right off the bat, I know that my S value, my sample standard deviation, is the square root of that, which is still just 1. A level of significance is 0.05, and let's go from there. So based on this information, we have population mean not equal to, so that's going to be two-tailed, and then it's going to be population mean, and here we don't have sigma, so this is going to be sigma unknown. So let's go to my template. Do I need to add rows here? I definitely do. Add. Doesn't matter how many you add. If it's too many, whatever. We can always delete them later. Let's go to my template, and we want a two-tailed mean, sigma unknown. Two-tailed mean. So here's my two-tailed mean, sigma known. This is one-tailed mean, so I'm going to have to go down. Two-tailed mean, sigma unknown. So I'm going to highlight this guy right here. That's what I want. Copy it. And I'm going to come in here and I'm going to paste it. Two-tailed mean, sigma unknown. Let's put in our information. Significance level is 0.05. My X bar is 8.2. My mu was 8.4. My sample standard deviation here is 1. And my sample size was 16. Okay? Now, again, we can use two different methods here. We can use the critical value or we can use the p-value. As you guys can tell, like we've done 5 examples so far, it's the same result every time. So let's do the little easier one and let's look at the p-value. Here my p-value is 0.44 and my significance level is 0.05. Well, here the p-value is higher than 0.05. If p is high, the null must fly. The null we would fail to reject. If p is high, the null must fly. We fail to reject. But let's actually answer the question that they wanted. Find the value of the test statistic. That's all they want. So here, my test statistic is this guy right here. Be careful, because since sigma is not known, my test statistic is actually a t. So my test statistic is this guy right here. Now, they said round your answer to 3 decimal places. Well, this looks a little suspicious. Like, what if they cut it off? I don't know. I'm going to come here and I'm just going to move the decimals out further. Ooh, it really is. So it really just is negative 0.8. All right, let's go to number 7. On number 7, a manufacturer of potato chips would like to know if its bag filling machine works correctly at the 425 gram setting. It's believed that the machine is underfilling the bags. A 16 bag sample has a mean of 420 and a variance of 256. That's a sample variance. It's in the same sentence. A level of significance of 0.025 will be used. Assume the population distribution is approximately normal. Determine the decision rule for rejecting the null hypothesis and round your answer to 3 decimal places. So I want you to go ahead and pause the video, find all the information that we're going to need for this problem. Okay, so from this problem, I got my null hypothesis of the mean is 425. The alternative is that it's less than 425. My sample size, my sample mean, my sample variance, and then I went ahead and found the sample standard deviation quick, and then my alpha. So from this alternative hypothesis, I don't know why that's there, from this alternative hypothesis, we can say that, okay, this is a one-tailed test, and it's pointing to the left, so that's actually going to be a left-tailed test, and still my sample standard deviation is known, so my sigma is unknown. So let's go to my templates, and I want one-tailed sigma unknown, one-tailed sigma unknown, and we're going to copy the whole table, and we're going to come over here and paste it in. Oh, and I don't have enough room. I didn't extend it, so I'll fix that in the future so we don't have to have this problem anymore. We will copy and we will paste. So I come over here, one-tailed mean sigma unknown. Let's put in all of this information. My alpha is 0.025, my x bar is 420, my mean is 425, my sample standard deviation is 16, and my sample size is 16. Okay? Again, what we want to find out, determine the decision rule for rejecting the null hypothesis around your answer to 3 decimals. Now, on Hawk's Learning, it's going to look like this. It's going to look like something, it's going to say reject H sub 0 if, so reject the null hypothesis if, and then since sigma is not known here, it'll have a T, and then it'll say less than, and then it'll have a box that you can put in your answer. They want to know what is the rule, like what does T have to be less than? Well, we know it's less than because of the alternative hypothesis, it's a left tail. Then we just have to come down here and find our test statistic, this negative 1.25. Nope, that's not right. The test statistic is what our actual guy is. We need to reject the null hypothesis. If T is less than, now we have to look at our critical value. That's our critical value. So if I had my graph right here, this is 0, and it's a left-tailed test, so it'd be negative 2.13. Boom, 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 boom. So we want to reject it if it's in this rejection region, which means it would be less than negative 2 point, and it said 3 decimal places, so 131. Now, let's find out. What do you guys think? Are we going to reject the null or are we not? So if I look at my test statistic, it's negative 1.25. It's right there. It's in the fail to reject region, so we're going to fail to reject this null hypothesis. Okay, finally what I want you to do on number 8, I would like you to try this one from start to finish all on your own. Come back and I will have the answer ready for you. Okay, so I have all the information put in, and I even went ahead and got the template and put that all into it. And you'll notice this is going to be a one-tailed mean with sigma unknown. So when I put that all in, I got my critical values, my test statistic, my p-value. I'm going to use the p-value method here. I got 0.003, where my significance level is 0.025. Here, 0.003 is less than 0.025. So if p is low, the null must go. That means we have to reject the null hypothesis.